this video, we will walk through the process of taking two cookies, detecting anomalies using the Raspberry Pi AI camera along with Sony Brain Builder for AITRIOS. I have two cookies here, one normal and one that has an anomaly. We are going to go through the process of collecting the data we need through the Raspberry Pi AI camera, pushing it to Brain Builder, building it in Brain Builder, exporting it, and then running the anomaly detector model on the Raspberry Pi AI camera. Let's get started. Now, the first thing we need to do is gather our data. If we take a look at the Anomaly Recognizer section in the documentation, it tells us how to prepare our dataset. And we'll take this criteria in mind as we begin to prepare our dataset. Okay, now we have the GUI tool open, and we are going through the process of capturing our data using the GUI tool. When the GUI tool first starts, you'll see our custom network option. You can take a look at our camera preview, but what we want to do first is go to images. And we would like to capture images of normal state. According to the documentation, we should capture about 50 normal images. So you'll see here I have my normal cookie and I have my anomaly cookie. The great thing about the GUI tool is it lets us set a timer for how often the pictures are taken. So we want to do about 0.1. This is going to give us 10 seconds per capture, and we want to capture 50 images. Okay, we're ready to get started. Okay, now that we've finished with our normal state, we can start working on our anomaly state. So we'll go to our collections, we'll create a new collection, and we'll call that collection Anomaly. Then once we get our collection created, we'll go in and start capturing our anomaly images. Okay, now that we've captured our normal and anomaly images, we're ready to download them. So to download them in the GUI tool, you just click the wheel here, click download, select the folder, and then you'll get your normal images, and then we'll download our anomaly image. The first thing we'll do here is create a new project. Call this and now we will create our data set. So we'll click here, create new data set. We'll click on upload data, and then we'll do dynamic training and validation sets for this data. We are going to use file-based upload. With folder-based, you would organize everything into one zip folder, name by folder name, so your anomaly and zip folder would be in the zip. Because we've downloaded them separately, we'll stick with the file-based and do a separate download. So what that means for us is that we will go to normal, and then we'll browse for the data we just downloaded and click on normal, and then we will upload that normal data. Once our 50 normal images have been processed, we will then go back and upload our anomaly data. Okay, now our normal upload is finished. Look at our upload details, and we can do upload again. And now we want to upload our anomaly data. We'll go click browse, and then we'll select our 10 anomaly images. Okay, and now our upload is complete. Now that we've uploaded our data, we can evaluate some information about the upload. And if you look at the numbers here, Brain Builder actually has great performance, 100% accuracy, 100% recall. We'll take a look at these numbers again after we train, but I think things look pretty good so far. If we flip through the images, can check to be sure that everything is categorized correctly. The anomalies are predicted as anomalies and the normal ones are predicted as normal. I think in the end, this is a really good result, and we are ready to move on to the next step. Now it's time to run the Anomaly Hi-Fi model training. This step will allow Brain Builder to not only detect anomalies, but also generate a detailed heat map that highlights exactly where the problem areas are. By training this model, we'll teach it to recognize the anomaly in the cookie and pinpoint its location. So if we go to the Evaluate tab, to the Anomaly Hi-Fi, we'll see the options we have are the ability to set the duration and the defect size. In our case, Brain Builder has defaulted to the thorough optimization, which will test against every model, and it's opted for the regular defect size. I think will fit perfectly for our model. Let's go ahead and train the Hi-Fi model. Now our training is complete. Time to evaluate our Anomaly Hi-Fi model build. As you can see, we have again a good result from our model build. Let's go in real quick and take a look at some of the results on our images. So even though we have a lot of pixels on our heat map, we are actually getting a good result here. So in the next step, let's go ahead and adjust the sensitivity of our heat map. Now, for one of the cooler features of Brain Builder, the ability to adjust the settings for the heat map. Now, as you've seen, the heat map overlay for normal and anomaly images looks about the same. Our anomaly images are covered with red and our normal images are colored in red. What we want to do is adjust the heat map settings. And when you make these settings, even though we adjust them individually for cookies, these settings apply to the entire project. What we'll do is we'll just increase the sensitivity a bit here. Let's increase the sensitivity until we don't see any red on our normal image. So let's go click through our normal images. All these look pretty good so far. And then we get to the anomaly images. I'm going to just focus on the big anomaly. About right there. And I think that this result looks pretty good. We can change the opacity if we want to. Opacity is about okay. And then we save this. And now when we export this and push it to the Raspberry Pi, these heat map settings will be saved. And these are the results we'll get when we look at this on the actual Raspberry Pi AI camera. Okay, I think we're ready to move on to the next step. So normally in a production level environment, you would do some testing before you release this. Brain Builder has a fantastic testing system. This system allows you to take images and drag them on and see how your model performs to new image data. Normally in testing, what you do is you take images that are not a part of your data set for testing. But in this case, I am just going to grab a few anomaly images, test them against our model, and see what Brain Builder does. And as you can see, it's recognizing all of these as anomalies. And I'm also going to grab some from the normal data set. This is just to show you how testing works inside Brain Builder. And then once they're in there, you can test and evaluate. You can upload a zip file, you can upload more images, but you can test until you feel comfortable. And then once you feel you are comfortable, you're ready to move on to the next step. Okay, we're drawing to the end here. We're now ready to move on to the last step in Brain Builder, which is exporting our brain. And to export, we just move over to the export section and we click on the download brain button. And then we now have our downloaded brain. And we've downloaded. Now that we have our exported brain, we are ready to visualize it on the Raspberry Pi AI camera. To do that, we will be using the GUI tool to upload and visualize. What we have here is a mapped drive to our Raspberry Pi AI camera, because we will unzip this and we will run the documentation to get our network.rpk file. But for now, let's go into the GUI tool. Let's create our network, and we'll call this, our model type will be RPK. Then anomaly detection, we'll stick with an RGB format. So now what we need to do is get our network.rpk and our labels.txt. Okay, now what we need to do is unzip our dataset on our Raspberry Pi. And once we unzip that, we will actually see inside of our exported brain the actual data zip file named after our dataset. And we will want to export that one as well, because that one will contain our labels.txt file and our packerout.zip file. Okay, so one thing we do have to do here is, again, generate our network.rpk file. So we will copy this one line here from the documentation to generate that file. So we'll copy this, go back to our Raspberry Pi, and let's just open a terminal right here. Then we'll paste in that one line, generate our network.rpk file. Should be able to come back here. See our network.rpk. Okay, so now that we have our network.rpk file, go back to our GUI tool, and then we'll select that file, .rpk file. Then we'll also select our labels.txt file. Click create. And now we have our own custom anomaly network. Okay, now that we've created a custom network and we have selected it, we can now look at a preview to see how it's being picked up on the Raspberry Pi AI camera. And you'll see that it's finding our anomaly cookie right here. And if we swap this out for our normal, see that it's not picking up anything on that cookie. And we swap in our anomaly cookie. Good job of finding anomaly. So to summarize, we created a data set for our Raspberry Pi AI camera. We ran the entire process through a brain builder, now reviewing the export on the Raspberry Pi AI camera. Hopefully this video has helped anybody who wants to use the system. Please let us know if you have any questions. Thank you.